Everyone, welcome to the another very important session in which we will be discussing some more important questions and the concepts for our upcoming CSIR-net and the GATE physics exam. So I hope that the discussion which we will be doing today in this session will be getting clear to all of you. But in case if anywhere you are gonna have any doubt in the discussion we will be doing today in the session, you can surely let me know about it then. And guys, I'm initially gonna tell you something related to the free trial which you can start. So this is like the steps I'm going to explain are to start your 7-day free trial. And guys, what you have to do to get it start, so basically you can enter your phone number first of all, and you can also see the steps on the screen. Step number 2 will be you can verify your phone number with OTP. Then step number 3 is you have to choose your target exam like CSIR UGC net. Next is you have to enter the activation code and then download the app to start your preparation. These are the steps you have to follow to start your 7-day free trial. I hope each and everything is clear to everyone now. And now guys, we are gonna go ahead to do the more discussion about the Unacademy learning app and the steps you can follow. Very good morning, Shantanu. Very good morning, everyone. So actually guys, here are a few more slides like this one. So it's gonna tell you about the Unacademy learning app, and then here is this slide regarding the session itself. This is something about me. This is about the community feature we are gonna have on Unacademy learning app, which will be helping you to stay updated and to know about the important things. Next we are gonna have is the important slide which will be helping you to know about the Unacademy Plus Iconic and the Lite subscription, that what is the difference between different subscriptions and how they will be helping you to take your preparation to the next level. So you can have a look at this slide right now. And also guys, now we are having the important notes available on the learning app, which will be helping you a lot to take your preparation to the very good level under the guidance of top educators. Also guys, in upcoming days, many new courses by the top educators will be starting on Unacademy. Along with that, whenever you will proceed further to take the subscription, you can use and apply the code that's Anjali Alive to get the discount in the total subscription amount. Okay, now let's start the discussion about the important questions and concepts we will be considering in the session today. So today we are going to discuss the important questions from the condensed matter physics, guys, and I'll be giving you the questions one by one from the condensed matter physics part. If anywhere you will be having any doubt, you can tell me about it, and if everything is getting clear, like whatever we will keep on considering, then it's great, and I'll keep on giving you more and more questions from different topics and the concepts. So let me just give you the first one right now, and one by one we'll take the other questions too. And today's discussion will be for condensed matter physics. Since there are like the topics we already know which are very important in the condensed matter physics, guys, I'll try to include the questions from those topics first of all, like in the session, and after that like the other related topics also we can consider. So let me just give you the first question. Here it is, guys. If the number density of a free electron gas in 3 dimensions is increased 8 times, its Fermi temperature will Options are increase by a factor of 4, increase by a factor of 4. Next one is decrease by a factor of 4. Option C says increase by a factor of 8. Option D says decrease by a factor of 8. Okay, now guys, the most important thing here to understand for anyone who wants to do the best preparation, who has already started the preparation, or even if somebody is there who is thinking to start the preparation, like at any stage of preparation you are right now, the most important thing you need to consider is that what to know. Okay, basically you will have different type of questions in the exam, so what you need to know to answer those questions, and that's a very important part of your preparation, because if you open a book you can see there are so many things in the book, right? But if somebody is there who is sure about this part, like what he or she needs to prepare and what they find important, so it will become easy for them, okay, to answer any question. So that matters, right? If you will look at this question, they have given you if the number density of a free electron gas in 3 dimensions is increased 8 times. So what is increasing? The number density, right? So number density is increasing. Let's say I'm going to call it rho n. And how many times it's increasing? That's going to be 8 times. And since it is 3-dimensional case, so I'll say its number density showing the number of electrons per unit volume, because it's a 3D case, right? It's becoming the 8 times now. Now, if we are going to talk about the further thing, so its Fermi temperature will increase by what factor? So here, what you need to know? You need to know what is the Fermi temperature. And if somebody is there who is not familiar with the Fermi temperature, so I can give you an easy way to memorize it. It's not necessary that you have to prepare all the formula for the Fermi wave vector, or you can call it the radius of Fermi sphere, along with that the Fermi energy, the Fermi temperature, and the Fermi momentum, right? So it's not necessary that you have to memorize each and every equation or the formula separately. It is possible for you to write any of the equations even if you're just preparing the Fermi wave vector or the radius of Fermi sphere you know about. But how it's possible? So let's say somebody knows about the KF. This is the additional information for you guys, because it will be helping you a lot to prepare this topic and to get ready for your exam related to this section. Okay, very well. So let's say somebody knows about KF. Let me just tell you, KF is the Fermi wave vector or the radius of Fermi sphere. Now its value for the 1D, 2D and the 3D case will be different, right? So in that situation, what will happen? In that situation, if I'm going to talk about the energy, so you know energy is what? How it's related to the KF. So even if not directly, you know P is equal to H cut K, right? In general. So H cut KF. And also you know E is equal to P square over 2M. So P is what? P is going to be the momentum, Fermi momentum, when you are writing it in terms of Fermi wave vector or the radius of Fermi sphere. At the same time, if I will talk about the Fermi temperature, that is going to be what? KBTF. Its E is equal to, in terms of Fermi temperature, KBTF. So once you know about the energy, you can find the TF2. That's going to be just divided by KB. So you just have to know the basic relations, and when you know the basic relations, just by preparing KF, which is the radius of the Fermi sphere or the Fermi wave vector, it will be possible for you to write any of the expressions. Okay, I hope it's gonna be helpful. Done? Okay, great. if I'm going to talk about the next thing now, guys, so what is the Fermi energy corresponding to the 3D case? Let me just write it. So it's going to be kf. Instead of writing kf, let's write just the ef. Okay. See, so if I'm going to talk about the Fermi energy related to the three-dimensional case, we had the formula for this one, that is h square over 2m 3 pi square the number density n to the power 2 by 3. Okay, this is the formula. Whenever you will study this topic in detail, you will be preparing all the formulae. So if there is someone who didn't prepare it yet, you can get to know about it. It is just for the 3D case, right? Now, once you know this, now in the question they have mentioned that the number density has been increased by 8 times. So 8 times means it's gonna be 8n, and 8n means 8 will be giving you to the power 3, right? So it's going to be to the power 3 to the power 2 by 3. Done? So it's going to be 4. So everything else will be remaining same except this new number, which is 4. So that means the Fermi temperature, because you know E is equal to kBTF, right? So in whatever way the energy is increasing, the Fermi temperature will also increase by the same factor. So very good, Shantanu, that is correct. Your option A will be the correct answer because it is increasing by a factor of 4. Okay, please tell me if in case still anybody is having any doubt in this part, we can talk about it. But if it is getting clear, guys, we can take the next question. And if anybody is still having doubt, mention it. We can talk about that part. So your next question is the radius of the Fermi sphere of free electrons in a monovalent metal with an FCC structure in which the volume of the unit cell is AQ is, options are 12 pi square over AQ to the power 1 by 3. Option B is 3 pi square over AQ to the power 1 by 3. Option C is pi square over AQ to the power 1 by 3. Option D says 1 over A. Now, let's try this one. Again, it's something related to what we have talked about in our last question, but at the same time, you will be getting more idea about the dimension, the formulas related to that part, right? So I think it's gonna make more things clear to you. So we are gonna go ahead with this question right now. And if anybody is there who knows or who can get the final answer, just mention it. We can talk about that thing too. So the radius of the Fermi sphere of free electrons, okay, in a monovalent metal is what? Metal with an FCC structure. So let me know if you can get it. Done? Let me know if there is any doubt. Clear? Okay, so the radius of the Fermi sphere of free electrons in a monovalent metal with an FCC structure. So again, FCC is what? It is three-dimensional case, right? In which the volume of the unit cell is A cube is what? So that's what you have to find. Shantanu, you got B. Okay, let me just explain this once and I hope you will be able to understand that how it will work. So actually in this case, the radius of the Fermi sphere of free electrons in a monovalent metal with an FCC structure, right? So do you know how many effective number of atoms you will have in case of FCC structure? It's going to be 4, right? Depending on how the atoms are arranged, where they are present, like on the vertices, at the face center position, okay, like that. So when you consider effective number of atoms there in FCC case, you get effective number of atoms equal to 4, right? Now radius of the Fermi sphere in case of 3D case. Why? Because FCC is a 3D structure. So from here even you can get it. It's 3 pi square n to the power 2 by 3. Reason? Because you know E is equal to P square over 2m. So P is what? H cut K. Okay. So K or KF. And if you will compare with that, the 2m is there, the 2m is there. P square is H cut KF. So H cut square is there. Now remaining is KF is squared, right? So KF for 3D case is what? That's going to be 3 pi square n to the power 1 by 3. Done? So once you're going to have 3 pi square n to the power 1 by 3, now effective number of atoms you already know, and there n is representing the number density, which is n over v. So n is 4, right? And v is a cube as mentioned in the question. So now you are going to have 3 pi square n over v, okay, to the power 1 by 3. So 3 pi square n is what? 4 over v, which is a cube to the power 1 by 3, which is going to be 12 pi square over a cube to the power 1 by 3. This is how you are going to consider the option A to be the correct one. Please tell me, Shantanu, does it make sense? And is everything getting clear to you that why it should be option A and not option B? If still you have any question or something you want to ask, you can surely let me know about it. But if it is clear, that's great. So tell me if there is something not clear, we can discuss that part. But if it is, that's great. Okay, great. Very good, Shantanu. Now it's correct. I'll give you the next one now. Cos kxa plus cos kya plus cos kza, where E naught, B and A are constants. The effective mass of the electron near the bottom of the band is. So now you have to consider the effective mass of the electron near the bottom of the band. Just consider it and tell me if in case there will be any doubt anybody will have. I'll write the options on the next slide, or should I write it here so that everything will be on one slide? Let me just try to write 2h square over 3ba square, h square over 3ba square, h square over 2ba square. Option D says h square over ba square. Now try it and let me know if in case there will be anybody having any doubt. Otherwise, whatever is the right answer according to you, you can just mention it. Or guys, if you are not gonna get that, I'll be explaining it just in some time. So giving you some time to work on it. Otherwise, I'll talk about it in just some time. Very good, Shantanu. That's great. But I'll talk about it and you can check out whether it's the same option or something different. Okay, so don't worry, but you can have a look at the steps. Look at this. The energy is given. You need to find the effective mass. So firstly, we need to recall the formula of effective mass, how it is related to the energy. So m star is equal to h square over delta to E over delta k square, right? Now, in this case, what will happen? In this case, we are going to consider h square and the second order derivative of E, right? But the another important point here is near the bottom of the band. So you need to know near the bottom of the band, what will be the conditions which we have to apply on K. So K will tend to 0, right? So when K will tend to 0, it will give you, see, whenever theta tends to 0 for cos theta, so cos theta can be written as 1 minus theta square over 2. This is the trigonometric function related condition. So again, near the bottom of the band, K will tend to 0. So when K is tending to 0, the cos kxa can be written as 1 minus kxa square over 2. Okay, cos kya can be written as 1 minus kya square over 2. Same way, the cos kza can be written as 1 minus kza square over 2. Now I'll write it on the next slide. So now the energy expression becomes, very good Shantanu, now it's correct. So E naught minus B, and next you're gonna have is 3 minus kx square plus ky square plus kz square, which I'll write as k square a square over 2. So 3 minus k square a square over 2, right? And now in this case, it's going to be E naught minus 3b plus k square a square over 2. So b is a constant, E naught is a constant. When you will differentiate it with respect to k twice, you will get one time 2k and the other time just 2. So 2a square over 2, which is just giving you a square. Oh, b was a common, so b will be here as well. So ba square. So h square over ba square is your final answer. Now in these steps, you can observe that how I have included the condition that k tends to 0 from the near the bottom of the band point, and the effective mass formula we just used, and the smaller theta condition we used, right, which is related to trigonometric function. So that's giving us option D to be correct. You can still tell me if you're gonna have any doubt, we can talk about that part. But there are so many questions related to this section, guys, where they have mentioned the condition near the bottom of the band, at the bottom of the band, at the first Brillouin zone boundary, second Brillouin zone boundary, like that. So you have to observe the conditions, and whatever they are asking you to find, then you can easily find that part. I'm gonna give you the next question, but if there is anyone having any doubt, just mention it. I'll talk about that part, okay? Otherwise, next question is waiting for you guys. It's here. The dispersion relation which is like for electrons in an FCC crystal is given in the tight binding approximation by epsilon k cos kx a over 2 cos ky a over 2 cos ky a over 2 cos kz a over 2 plus cos kz a over 2 cos kx a over 2. These are the terms present in the expression, and next you're gonna have is where a is the lattice constant and epsilon naught is a constant with the dimension of energy. The x component of the velocity of the electron at pi by a comma 0 is, options are, now I'm just going to write them, 2 epsilon naught a over h squared, okay, 2 epsilon naught a over h squared minus 4 epsilon naught a over h squared, then 4 epsilon naught a over h squared. Try it now and let me know as you will get it done. Excuse me. If in case you will have any doubt or if you will be getting it wrong, guys, by chance you're not gonna get that, it's okay. I'll be helping you to work on it. But I want you to try, because if you are familiar with the formula, if you can think about the steps, what you will be taking, if you will get it right, it will boost up your confidence. But if by chance you will make any mistake, you will get to know where it's wrong and where you need to be extra careful. It's going to be good to know, right? So try it now and let me know if in case you will have any doubt anywhere. See all the details which are given. If you have to apply some condition depending on the statement mentioned there, so you just have to relate it. Waiting for your reply. Very good, Shantanu. But if you want to check it out, you can, so that you will get to know if you are making some mistake somewhere or is everything all right and clear. Otherwise, I'm going to start the discussion. Okay, guys, look at this. In this case, you're having the dispersion relation given to you, which is basically E versus K, right? So or sometimes omega versus k is even given in the question, so that's okay. So any of these can be given as dispersion relation, but right now we are having E versus k relation given to us. So when you have this kind of dispersion relation given to you, now what next they have asked you to find? They have asked you to find the x component of the velocity of the electron at pi by a comma 0 comma 0. So if we are going to talk about the x component of velocity, now you know, or you need to know the formula for the velocity, which is going to be like, there are two velocities we talk about. One is group, another one is phase, right? The phase velocity is basically, in general, if I'm going to talk about it, omega over k. Also, group velocity is basically d omega over dk. Now, how you will replace the omega in terms of E? That's the point. So we all know E is equal to h nu. But at the same time, if I'll multiply it with 2 pi and divide it by 2 pi, it will give me h cut omega, right? So once you will have the h cut omega, very good Shantanu, now it's correct. So you can write the omega is equal to E over h cut from here. Once you're going to write that, now what will be happening next? That's Vg is equal to 1 over k dE over dk, right? Now once you have considered that part, what next? The next thing is, since you just want to find the x component of velocity, you just have to take the kx. It's okay, Shantanu, but the good thing is that you are trying and you are trying to solve. So if by chance you're making some mistake somewhere, just focus on that part so that in the exam you will not be repeating that mistake, and you will get to know where there were chances of making mistake, where you need to work, where you need to improve, right? So that will be helping you a lot. That's the best thing related to the practice. Give me a second, guys. I'm just gonna see. No, I think this way it will be good. Okay, now it's better. We can continue. So actually, guys, if I'm going to talk about the next thing here, that's going to be 1 over k, okay? It's not k, it's h cut. 1 over h cut dE over dkx. Because you just want to find the x component of velocity, so you have to take the differentiation with respect to kx, right? And here, if you will see, kx is here, kx is here. So these two terms will give you some non-zero value because that's the partial differentiation. So when you're going to just differentiate it, after that you have to consider kx, ky, kz values, which are kx as pi by a, ky as 0, kz as 0. So when you're going to do that, let's see what you will get. Negative 4 epsilon naught as it is over h cut as it is. Now differentiate it with respect to kx. So when you're going to do that, cos differentiation will give you negative of sine. So negative and negative will become the initial negative, and the negative you are getting after differentiation, that will give you a positive sign there. So that means I can write it to be positive, and then cos kx a over 2 will give you just a over 2, and then sine kx a over 2, right? And the next thing is cos ky a over 2 will remain as it is. Then next, again you will get the negative of a by 2 sine kx a over 2, right? So negative will go common, which will give you just plus a by 2 sine kx a by 2. It's just the part of angle. Next is cos kz a over 2. If in case somebody is not getting anything, you can tell me, I can explain it to you again. Now kx, ky, kz are pi by a 0, 0. So pi by a just for kx, which will give you pi by 2 here, ky 0, kz 0, kx pi by a again. So sine pi by 2 will be what? That will be 1, and cos 0 will be 1 as well. So a by 2 is there. You will have in the first part a by 2 in the second term. Like, so a by 2 plus a by 2 is a. So for epsilon naught a over h squared, that's your answer, which is option D, which is the correct one. Tell me if in case there is still any doubt anybody is going to have, we can talk about it. But if it is clear, that's great. Let me know, let me know. Whether everything is clear or not. If you have any question, query or doubt, just mention it. Otherwise, I'm going to give you the next question now. Okay, next is like quite a fact-based question, right? Let me just write it. Which of the planes corresponding to the Miller indices? Okay, so I just have to write the planes here. Given below will not give rise to Bragg reflection. Two two zero 242 221 311 220 242 221 311. Okay, try it now, and if you know what will be the right option, you can even mention it in the comments. If you don't know, I'll help you in that case, don't worry. So if you already know what will be the right option, just write it. Very good, Shantanu. That's great. So here they have just clarified like, okay, this is NaCl structure and this is FCC, which is the face-centered cubic, right? They have mentioned all that. Now, if we know about the selection rules related to the FCC structure, so what is that? That either HKL all should be even or all should be odd, right? So if there is going to be a mixture of even and odd, you can't get the reflection, or you can't see that X-ray diffraction or any kind of diffraction. So basically, if you will see, The option A is showing you 2 to 0, which is all even. We can consider 2 4 2 all even. 2 to 1, it's a mixture of even and odd, which means we can't observe the Bragg reflection for the option C. And option D, it's completely odd numbers are there. So option C is the correct one because they are saying will not give rise to Bragg reflection, right? So that's what you have to consider. Tell me if in case there is anything not getting clear to anyone, we can talk about it. But if everything is getting clear, then that's great. Okay, let me just write the next one then. There is a formula based question. I will be considering that one right now, so that even you will be able to recall the formula, guys. A DC voltage V is applied across a Josephson junction between two superconductors with a phase difference phi naught if I naught and K are constants. That depend on the properties of the junction the current flowing through it has the form. Options are I naught sine 2 EV over h cut plus phi naught. Let me just write it. Try it now and let me know as you will get it done. Whatever you think is the right formula here, that's your right answer. But if you are not getting it, I'll be helping you in that case. So actually, okay, I'm gonna wait for everyone's reply for just some time and then I'll talk about it. So in this case, they have given you a DC voltage V is applied across a Josephson junction, okay? And this is basically related to the Josephson effect. So between two superconductors with a phase difference which is phi naught, if I naught and k are constants that depend on the properties of the junction, then the current flowing through it has the form, like what kind of current expression we get. That's what they're asking you to find, right? Very good, Shantanu. That's correct. So it's option A, which is going to represent the correct expression of the current, which is I naught sine 2e vt over h cut plus phi naught. Okay. So anytime, even this is the question where they have given you the options as the formula. Okay. Which means what will be the expression and what is the correct way of showing it. But at the same time, sometimes you can have the numericals, means the questions based on it, where they will ask you to find some value, to write it, and that's how like it can work. So you can prepare the formula for it, which is same as option A, and that's showing you I naught sine 2e vt over h cut plus phi naught. What is I naught here? So all the details they have given you, I naught and k are constants, phi naught showing you the phase difference. Okay, so once you are gonna have the DC voltage as V, you can see all the things, right? And anytime if you will have similar kind of question in the exam, you can just answer it quickly and easily because you have all the details about the formula, so it will be easy. You can tell me still if you're gonna have any doubt, we can talk about it, but if it is clear, I'm gonna give you the next question. So our next question is again something we have talked about in the session. Related to that, we are going to have our next question. So if you got that part, you will be doing it right. The dispersion relation of phonons in a solid is given by omega square k is equal to omega naught square 3 minus cos kxa minus cos kya minus cos kza. The velocity of the phonons at large wavelength is. Options are omega naught a over root 3, omega naught a, root 3 omega naught a, and the next one is omega naught a over root 2. Tell me if in case you're gonna have any doubt, we can consider that part then, but if everything will be clear, that's great. You can go ahead to solve it and let me know whatever is the right option according to you. Or otherwise, if anybody is not able to relate the formula, I'll be helping in that. The dispersion relation of phonons in a solid is given by this. Waiting for your reply, guys, and then I'll be continuing the discussion. Very good, Shantanu. That's great, and that's correct too. So actually what you have to do, you can again see they're talking about the large wavelength. So we need to know k is equal to 2 pi by lambda. So when the wavelength is large, k will be small. When k is small, the theta here is small because of the cos theta. Theta has the k in it. So then again we will have to write it as 1 minus kxa square over 2, 1 minus kya square over 2, right? And 1 minus kza square over 2. So once you're going to consider that part, you will be getting the omega expression from there after simplification. So you will have omega square is equal to omega naught square, 3 will get cancelled out, plus okay, just omega naught square, 3 will get cancelled out, k square a square over 2. Why? Because kx square plus ky square plus kz square will give you k square, the sum of all those. So k square a square over 2. Now it's giving you omega is equal to omega naught ka over root 2. When you want to find the velocity of phonons, that will be d omega over dk or omega over k. Both are giving us the same answer here, which is omega naught a over root 2. Hence your option D is the correct one. Please let me know if in case there is anybody having any doubt, we can consider that part then. But if it is clear, we'll take the next question. If anybody will have doubt, they can mention it in the comments, guys. Otherwise, next question is, a flux quantum, which is fluxoid, is approximately equal to 2 times 10 to the power negative 7 Gauss centimeter square. A type 2 superconductor is placed in a small magnetic field. Which is then slowly increased till the field starts penetrating the superconductor. The strength of the field at this point is 2 over pi times 10 to the power 5 Gauss. Now you have to find the penetrating depth of this superconductor. Options are 100 angstrom, 10 angstrom, 1000 angstrom, or option D says 314 angstrom. Just try it now and let me know whatever you think is the correct option. And if you're not familiar with it or you are not able to get it, I'm gonna help you in that case. I'm just gonna consider, guys, what is the right answer. You guys are gonna consider, or otherwise I'm gonna start discussing it. Okay, that's all right. But the good thing is you tried, right? Now let's go ahead. So actually you are gonna have the fluxoid given to you, which is phi naught, let's say, which is 2 times 10 to the power negative 7. Then a type 2 superconductor is placed in a small magnetic field, which is then slowly increased till till the field starts penetrating the superconductor. So there are two things. The one is, like, when we talk about the type 2 superconductor, what happens in that case? It doesn't lose its superconductivity behavior instantly, or you can say at the same time when the field starts penetrating within the superconductor. How it works, like type 1, it is just gonna become a normal conductor from a superconductor at the same time as the field starts penetrating. Means it's like not gonna take much time to convert, right? But if we will talk about the type 2 superconductor, once you apply the increased strength magnetic field on the superconductor, the field starts penetrating at a point within the superconductor, then slowly it enters, increases, and then after some time it becomes the normal conductor. So there are two fields. One, when the field starts penetrating. The other one, when it can completely penetrate within the superconductor, where the superconductor will become a normal conductor, right? So in that case, there is going to be first magnetic field and the second magnetic field strength, which is when the field is completely inside it, like goes completely, right? So for the first case, you try to find the penetrating depth, right? So in that situation, you are going to talk about HC1, and it's going to be phi naught over pi lambda square. Well, lambda is also known as London penetration depth. The second time when the field will be completely penetrating within the superconductor, you will talk about the coherence length. Okay, so there are two things. One, the London penetration depth, and the other one where the field is completely penetrating inside the superconductor, it's the coherence length, right? So in this case, you need to find the lambda, and you have the initial magnetic field when the magnetic field has a starting to penetrate within the superconductor. So that's going to be your HC1 is 2 by pi times 10 to the power 5. What about the phi naught? That's going to be 2 times 10 to the power negative 7. And then you need to find the lambda value. So lambda is 2 times 10 to the power negative 7 times pi divided by 2 times 10 to the power 5 and then pi. That's it. Pi cancelled out, 2 cancelled out. It will give you 10 to the power negative 12 and the 10 angstrom. The 10 to the power 10 power, like the power 10 will give you the angstrom unit, negative 10. And other than that, 100 will be remaining there. Is it 100? Yeah. So your option A must be the correct one, right? Because it will give you 10 to the power negative 12. You can write it as 10 to the power negative 12, right? Let me just check out the values here, guys. What values you have and what you're gonna get. Okay, it was centimeter square. Can you see that? So when it is centimeter square, you also have to consider the 10 to the power 4, that's negative 4, to convert it into meters. This is for 10 to the power negative 7 units. See, 1 meter, 100 centimeter, 1 centimeter, 1 over 100 meters, right? And that's how you are just going to consider it. Now you can simplify this part and you will be getting the value of lambda. This was lambda square actually. So 10 to the power negative 7, 10 to the power negative 4, which is giving you 10 to the power negative 11, and then 5 more, that will give you 16. 10 to the power negative 16. That's your lambda square. So lambda is equal to what? 10 to the power negative 8, right? And now you will multiply it with 100 and divide it by 100. So divided 100 will give you angstrom because of that negative 8 already present there. So 10 to the power negative 10 you will have. And now it's in meter. So 10 to the power negative 10 meters will give you angstrom. So 100 angstrom, which is option A, and that's the correct option. You can tell me still if you're gonna have any doubt, we can talk about that part. But if everything is clear, that's great. Okay, guys. So I hope that point is clear, that when you are gonna consider type 2 superconductor, how the things work and how they are gonna tell you about the type 1 and the type 2 related magnetic field. So only for type 1 you will just have one magnetic field value. For type 2 you have the initial, when the field starts penetrating, and the second one, which is when the field completely goes inside the superconductor and your superconductor becomes a normal conductor. So these are the two different fields you will have in that type 2 case. Type 2, two magnetic field strengths. The first one is related to London penetration depth. The second one is related to coherence length, right? If you will keep it in mind, you will not be making any mistake anytime. So guys, right now we can keep it this much today in the session. If in case you're gonna have any doubt, you can mention it in the comments. But if everything is clear, that's great. So thank you so much everyone for joining this session and for attending it till the end. Thank you. Bye. Take care. Let me just quickly show you the slide which will help you to know about the difference between the plus iconic and the light subscription. So if you will take the plus iconic or the light subscription, how it will help you to take your preparation to the next level, what are the benefits you will get. And also guys, now the important notes are available on the learning app, which will be helping you a lot to take your preparation to the next level. Also guys, you can apply the code that is Anjali Alive to get the discount in the total subscription amount. Okay, thank you so much everyone for joining this session and for attending it till the end. Even so many new courses will be starting on Unacademy by the top educators in upcoming days. So if you don't want to miss those courses and you want to join them, you can take your subscription and start your preparation under the guidance of top educators. Thank you so much everyone for joining this session. Bye. Take care. See you soon, because we are going to have so many sessions here right now, like in recent time, right? So you all can join them.